Hello everyone. Today we are going to see about types of blockchain nodes. Every blockchain claims to be decentralized, but a decentralized among whom? The answer is nodes. Today we are breaking down the different types of nodes that keep a blockchain network alive and why not all of them do the same job. One quick refresher. A node, what is node? A node is any device that connects to the blockchain, follows its consensus rules, and helps maintain the ledger. There is no central server. Every node talks directly to its peers. See the diagram. But maintaining the ledger can mean very different things depending on the node. That's what we are unpacking today. See here, there won't be a central node. All the nodes are interconnected. Now we are going to see about full nodes. First up, full nodes. These download and store the entire blockchain history and independently check every single block and transaction against the rules. They do not trust anyone else's word for it. Now, Bitcoin Core and Geth for Ethereum are examples of full node software. Running one takes real storage. Bitcoin's chain alone is several hundred GB. Full nodes are what actually enforce the rules of the network. Miners and validators propose the blocks, but full nodes reject anything invalid. If a miner tried to slip in a valid transaction, who would catch it? A full node will catch it by rejecting the block. A full node is like a librarian who owns the complete set of records and checks every new page before solving it. Light nodes. Not everyone can store hundreds of gigabytes. Light nodes, also called SPV clients. SPV means Simplified Payment Verification. Download only block headers and ask full nodes to prove a transaction is included. This is what most mobile crypto wallets do. It's fast and lightweight, but it means light nodes place a degree of trust in the full nodes they query. This slide shows the light nodes. You even compare the full versus light. Full nodes will have a whole detail. Light nodes won't have the full data of the block. Next one, mining and validator nodes. Mining nodes are the block producers under proof of work. They race to solve a puzzle for the right to add the next block, like we covered in the mining video. Under the proof of stake, validated nodes take that role instead, chosen based on how much they have staked, not how much electricity they burn. Both roles are almost always paired with full node capability, so they can check the block they are proposing is actually valid. Proof of work minus equal to specialized hardware and electricity. Validators mean staked capital and uptime. Next, we are going to see about archive nodes. A regular full node keeps enough state to validate new blocks, but it can prune old state into no longer needs. Archive nodes keep everything, every historical snapshot ever. This is why services like Etherscan or Blockchain.com Explorer, the ones you used in the Explorer activity, depend on archiver nodes behind the scenes. Direct tie to the Blockchain Explorer activity deck. If you did the hands-on activity, then you will understand the what is archive data actually. Next is master nodes. Some networks add a fourth rule, master nodes. Op- Operators lock up a required amount of collateral, and in exchange their node handles extra services. Instant transaction, governs votes, sometimes privacy mixing. This isn't universal, it is a design choice specific to certain protocol, not a category every blockchain needs. This is a comparison table. We are going to compare the full node light mining and validated node, archive node, master node. What it stores, what validates, produces blocks. Let's line up them all up. Full nodes store the current chain and validate everything. Light nodes store almost nothing and lean on trust. Miners and validators are full nodes with an extra job, proposing blocks. Archive nodes store the entire history, not just the present. And the master node add optional services on top. Now we are going to see how they work together. None of these run in an isolation. A mining or validator node proposes a block. Full node across the network independently check and accept it. Light nodes ask full nodes to confirm their transactions landed. Archive nodes keep the permanent record for anyone who needs history. It's a division of labor, not a hierarchy. No single node type is an in charge. So why does this taxonomy matter? Because decentralization isn't just about having many nodes. It's about having many independent, differently resourced nodes. Resilience. No single node type can take the network down. Accessibility. Light nodes bring in participants who could never run a full node. Accountability. Archive nodes keep a history nobody can quietly erase. Let's lock it in. Full node store and validate everything. Light node leans on SPV to stay lightweight. Mining and validator nodes propose blocks. Archive nodes holds the full history, and master nodes add optional extras on the sum chain. This is what the types of blockchain nodes.